Hey guys, what's up? See, I'm back here, and what I'm here with another very important topic, and that's from Biomolecule this time. And in case you remember what we were doing last time, that was very important, thing that we were doing. We were doing a couple of reaction. We were describing, why the glucose is having a structure of what we had then, right? But what today I'm doing, that is very important, very important, even way more than that one. And this is called cyclic structure of glucose. So today I'm going to describe you cyclic structure of glucose. In the coming section I will describe you why there has to be a cyclic structure of glucose, right? So there's two topic in sequence I'll be doing. The first, which I'm taking today, this is about how you can draw the cyclic structure of glucose. Remember, this has been a tough topic for many of the students. So I'm sure after watching this very lecture, they will have even that solution in their mind, that how the structure is coming out to be, right? Just pay attention, find out what I'm doing, right? So we are talking about cyclic structure of glucose. But in order to do that, the first thing we need to know is that what is hemiacetal. This is not something I'm doing for the first time, but I'm repeating it back here. So that hemiacetal is something that is going to be used in the cyclic structure of glucose. So what I'm doing right now, I'm first taking you through the hemiacetal formation, right? What is hemiacetal? Let me repeat back. A hemiacetal is a compound that is formed by either two compounds, one is having aldehyde, other is having a alcohol group, but this is called inter hemiacetal compound. Why inter? Because we are using aldehyde as a compound and then alcohol as another compound. But in the glucose, I'll be describing you intra-hemiacetal formation, because that is the reason why cyclic structure of glucose is formed. But before that, let's go with the simplest hemiacetal formation, and then you will know what I'm talking about. So like I said, our topic is hemiacetal. So I'm placing a topic here, hemiacetal. So let's start the reaction and find out what this is. I'm taking taking an aldehyde here. This is oxygen here, and there you have your hydrogen. Now I'm taking another molecule which is of alcohol, right? Which is of alcohol. You do know alcohol has a lone pair right here. Now just pay attention. This carbon is in electron deficient condition. Why? Because it is next to a electronegative atom. So what will happen? This carbon electron deficient will be fulfilled by this very oxygen, right? So this is coming to rescue the carbon, but by doing so, what will happen? This bond must undergo cleavage, and this will go to the oxygen, and in that case what's coming out to be? This is coming out to be R. You got your C, now you have O, right? O with a negative charge, and there you have your oxygen, there you have your oxygen, and this oxygen is having, an alkyl group, right? And there you have your hydrogen, but this oxygen is having a positive charge because this donated its own electron, right? Now there is one more hydrogen also here. In the next step, what happened? Just pay attention. This is very important. What happened? Because the oxygen had donated electron, so what will happen? This will result, taking its own electron and become stable. So this bond will undergo cleavage. This proton coming out will approach to the oxygen. And due to that, you have your hemiacetal coming out to be. And what this hemiacetal is? You have R, you have C, you have OH here now, and then you have OR, here, and along with that you have a H also here. So what I just did, I just make this hydrogen go with the oxygen, this become alcohol, and this remain as OR only. Just pay attention here. So this is called hemiacetal. This is very important. Why? Because this is the structure you will be using in order to make the cyclic structure of the glucose. Let me repeat back. An aldehyde molecule, when comes in contact with the alcohol molecule, the aldehyde carbon, because it is electron deficient, electrophilic by nature, so the oxygen of the alcohol will go to the rescue, right? And in that case, oxygen will make a bond with the carbon, but in order to do so, the pi bond must be breaking away. And after that, what we have done this development right here. And then what you can see, because this oxygen electron deficient, so it will result sacrificing one of its proton here, and the proton coming out from here will go to the oxygen. This become OH, and this will remain as a alkoxy. Right? So this is also called alkoxy alcohol. Let me tell you, this is also called alkoxy alcohol. So this is a hemiacetal molecule. Now this is very important because I'll be using in the, if you remember the structure of glucose, what we had this structure, right? We had this structure, oxygen, you know, there was a hydrogen here, there was a hydrogen, and then 4 carbon, this is the 4 carbon right here next, and the last one was as a CH2OH, right? This one was CH2OH, and the first one had hydroxide on the right hand side, the second one has hydrogen on the right hand side but OH on the left hand side, right? And then rest of all the carbon had OH on the right side. I have, you know, done this very lecture several times in just past couple of days, so I hope you remember each and everything I'm trying to make you go. So this is what your structure of glucose is, right? 3 of the hydroxide groups are on the right side. That's why this is the, you know, this is the dextrorotatory glucose, right? I'm not going big, you know, back deep into all that. But what we have to do here, just pay attention. What I'm doing, you know, a very important thing here. Pay attention. You know, this hydroxide group, right? And there is an aldehyde. So this is what is going to happen here. Pay attention right here. You know, I'm, you know, using this. This is your first carbon and this is your 5th carbon. Just pay attention. This is the first and your 5th carbon. So what will happen? You know, this 5th carbon oxygen. Why the 5th? I'll tell you in the coming section. That's very, very important thing, but not right now. Let's pay attention and get the structure. This 5th carbon oxygen will result, you know, coming to help the carbon here, but for doing so this carbon must sacrifice its pi bond, and then this oxygen will become negatively charged. By doing so this bond will undergo cleavage and this proton will go right over the oxygen. You know what I'm doing, you know, I'm placing that first carbon right here where the O is now in the form of a hydroxide. You know, you have your H here, and then the second one is having a OH right here, the third one is having OH on the left hand side, and you know the fourth one is again having its own hydroxide, while the 5th one, you know, is a 5th one. Just pay attention. This is, you know, what's coming out to be. Pay attention because this is how the ring is formed. And the last one is, there is no change here, CH2OH. This is what let's place the remaining hydrogen to their original places. So this is the, you know, thing you will get. So let's practice this, how this is coming out to be. What I just did formation of a intramolecular hemiacetal, where this, you know, oxygen is trying to rescue the carbon by donating its lone pair, but by doing so, you know, this oxygen will, you know, take its electron and become negatively charged, and this proton will shift to the O. So this aldehyde now will convert into a hydroxide group. So this is the oxygen which have now converted into hydroxide, right? And this oxygen will now combine with the carbon. So that I've done. The 5th carbon oxygen is now connected to the first carbon. So this is your first carbon here, this is your 5th carbon here. Pay attention, this is really, really important, you know. So this is how a ring is formed. Now I'm, you know, helping you to get it through your cyclic structure exactly, but just for a second I'm making it a bit shorter here. So this is what it looks like to be. Anyway, so I'm drawing here, you know, the cyclic structure exactly so that you will understand what I'm trying to do. You know, this is what a cyclic structure of 6 carbon molecule looks like. This is what the structure looks like. But what you need to do, this, you know, just place oxygen right here. Place oxygen right here. So what that means, this is your first carbon, this is your second carbon, third, fourth, and the 5th one. Now what you have to do, you have to place, you know, H and OH to their respective sides. You have to place H and OH to their respective side. Pay attention. All the OH on the right hand side, will be placed, you know, below. So let me write here, you know, OH on the right hand side, OH on the right hand side will be on below. What that means? You have to place them, you know, over here below, right? So let's 1, 2, 3, and finally you have 4. So this is going to be your OH here. This is again going to be your OH here, right? Sorry, this was your OH, and this is your hydrogen here. Second is again, but this one is not. So there you have your H, but this OH will be on the inner side. So this is the OH, and finally this is again, you know, OH out here, and this will be occupied by the this will be occupied by the, something like this. So there you have your H here, you have your H here, and you have your CH2OH, right? So you don't need to place any hydrogen right here. So this is what the, cyclic structure of glucose looks like to be. In case you need, let me, draw it back here so that you can understand again. Okay. What I just did, I made a ring here. I made a ring here, and this ring has, 6 carbon. This ring has 6 carbon. But right from here, I placed an oxygen, and on the remaining carbon, you have to place their, remaining parts. So there you have your OH, and you have your H here. There you have your OH, second one, and there you have your H, and this one doesn't have OH outside, so it's going to be in there. And then, this fourth one, 1, 2, 3, 4, fourth one is also having OH on the, right hand side, going to be below, and hydrogen, and this last one is having a CH2OH right here, right? So this is what the whole, structure looks like to be. So this is called the cyclic structure. What you need to do, you have to practice yourself, you have to practice itself. In case you need, watch it again, because unless you do that, you won't be happy with what I just did, right? So for some, it's maybe in the first attempt you have learned everything, but for some, those who are having, those who are struggling, they can repeat it back. It's all there. Any moment you wish to, you can go back and check out what what I just did. But this is really very, really very important. So I have to wind this right here, and I'll take you through the, next phase. And that's going to be in the next lecture. So thanks for watching. Take care and have a good day.